Hello everyone, my name is Snehal Srivastava. I have always found myself more inclined towards mathematics. I have pursued BSc in mathematics and statistics as my main subjects. Along with my graduation, somehow I started teaching CAT and other government exams students. After my graduation, I have decided to pursue MBA. But along with that, I have continued my teaching. After completing my MBA, I have got some career opportunities in corporate sectors as well. It was then that I realized I should take my teaching career to the next level where I get professional environment and more opportunities to grow. In my entire teaching journey, I have also worked with Unacademy and many other local institutes as well for ITJ faculty. One of the main reasons behind teaching is that it gives me happiness when I see my students growing in their studies and career as well. So I thought it is the right time for me to step into the ITJ coaching industry. So now let's start with complex numbers with iota. So in this chapter, in this small session, we will understand what iota means and how it helps us in solving most typical equations which are not easy to solve, but with the help of iota, we can solve it in some seconds or we can say in minutes. Okay. Now let's come to what is iota. Iota is nothing, but it is just a square root of minus 1, which is we can also say it's an imaginary number because if I ask you that which number is the square root of minus 1, you will be confused that what is the square root of minus 1. So we denote it by I, that is also known as iota, or you can also say an imaginary number as well. Okay, now I is equals to minus 1. So this is the basic thing you have to understood about iota, that what is iota? Square root of minus 1 is iota. Now let's move further. How you can solve the questions? To solve the questions based on complex numbers, first you have to understand about repetition of its values. Means repetition of iota, the values of iota. After how many powers its value gets repeated. Okay. So first we know it very well that I to the power 1 means iota is equals to under root minus 1, right? Okay. If we square it, what we'll get? We will get minus 1, right? Okay. If we do its cube, so we will get what? I square into I. That is minus I, right? Okay. Now, for I to the power 4, we can say I square into I square. That is minus 1 into minus 1. It's very easy. 1. So I to the power 4 is equals to 1. If we go further, I to the power 5, we can say I to the power 4 into I, which is equals to 1 into I. That is I. So we can clearly see here that the value of I is getting repeated after I to the power 4, means I to the power 5 is equals to I to the power 1. If we go further, we can see that I to the power 2 means I square is equals to I to the power 6 and so on. So how we can solve, how it gonna help us in solving the questions? Let's see. Let's come to the question. Let's come to the examples and see how these logic, these concepts gonna help us in solving the questions. Okay. Okay. Now, see, we can say any multiple of 4 in the power of I, any multiple of 4, like we can say 4 into 2, that is I to the power 8. We can say I to the power 4 into 3, that is I to the power 12, and so on. In each and every cases, when the power is the multiple of 4, the answer comes 1, right? Means I to the power 4. If we write I to the power 4k, where k is a constant, k is any number, so the answer will become 1. Got it? As simple. Okay. What if the power is not in multiple of 4? Means let's assume the power is 9. So we can write I to the power 9 as I to the power 4k plus 1, right? Okay. So I to the power 4k into I to the power 1. That is 1 into I. That is under root minus 1, or we can say iota, right? Okay. So again, with the help of this concept, we can say I to the power 4k plus 2 is equals to I to the power square. That is minus 1, or we can say iota square. And I to the power 4k plus 3, that is I cube, that is minus I. Okay. So we will write it down on the side because it's gonna help us in solving the examples. Okay. So I to the power 4k is equals to 1. I to the power 4k plus 1 is equals to under root minus 1. I to the power 4k plus 2 is equals to minus 1. And I to the power 4k plus 3 is equals to minus I, or minus under root minus 1, whatever you like to write. Okay. So you have to note it down. It's gonna help us in solving the difficult questions of IT JEE Mains or advanced. Because this concept of complex number is the basics which help you in solving the most difficult questions. Because without solving this, without understanding this concept, it's very hard. It will become hard for anyone to solve the further questions. Okay, now let's come to examples. So here we have examples. Before continuing for the examples, let me write down the important points here, that I to the power 4k is equals to 1, I to the power 4k plus 1, I to the power 4k plus 2, and I to the power 4k plus 3 is equals to, this is I, this is minus 1, this is minus I, right? Okay, nice. Now, with the help of this, we're gonna solve these questions. Now, whenever the question is like I to the power any power, like here it is given that I to the power 102. So we have to check that 102 is divisible by 4 or not. Means in which format we can represent it. In this, or this, or this one. So we have to check out. So for checking, we have to divide it. 4 2s are 8, 22. 4 5s are 20, and remainder is 2. So we can write it as in the form of I to the power 4k plus 2, right? Okay. So the value of 4k plus 2 is minus 1. Hence the answer is minus 1. Very simple. We don't have to do anything, right? Okay. It's very, very simple. We just have to divide the power by 4 and get to the answer. Now, in your question, in your mind, there is a question that, sir, what will happen if the power is in, if the iota is in denominator? Well, how we will solve this? So, if the iota is in denominator, you don't have to worry about it. Just do multiply in numerator and denominator by iota. So here we will get I upon I square. What is I square? We can say, sir, I square is minus 1. So answer is minus I, right? Okay. Now next question. So what if the iota with its power is in the denominator? How we can solve it? So first of all, you have to do the same thing as I have told you, that you have to divide the power by 4. 4, 20, hence the 3 is remainder. So we can represent I to the power 31 in the form of I to the power 4k plus 3, right? Okay. And do you know what is the value of I to the power 4k plus 3? We can say, yes, sir, we know its value. I to the power 4k plus 3 is the value of I ka cube, I is cube, right? Okay. So I cube is minus I. So the answer is 1 upon minus 1 by I, and we have already seen that 1 by I is equals to minus I. So let me erase it. We can write it as minus 1 by I, hence minus I. That is I. Got it? I hope it is visible to you. Okay. Now let's come to the next question. This is the basic method. By this method, you can solve any question of iota. No, sir. Now the next question, question number 4 says that what if a very big digit comes in front of us in the form of power? So what we will do? Again, the same thing. You have to follow the same procedure. You have to divide the power by 4 and check in which form it is. Like it's in the form of I to the power 4k or I to the power 4k plus 1, 4k plus 2 or 4k plus 3, whatever the power is. Okay. So we know that to check the divisibility by 4 and to find the remainder as well, we just need the last two digits of any number. Either it is this or this. So we will take the last two digits, 23, and divide it by 4. So we clearly know that 4 5s are 20 and remainder is 3. So it's in the form of I to the power 4k plus 3, that is minus I. Got it? I hope it's clear. Next. Next question, question number 5. Sir, this is a very huge number, a big number. How can we solve it? Again, the simple same process. You just have to take the last two digits, divide it by 4, hence remainder is 3. So it can be represented in the form of 4k plus 3, that is minus I. Simple. Now, if the big number is in the denominator, again you have to follow the same procedure. You have to divide the last two digits by 4. So what will we get? The remainder is 2. So it can be represented in the form of I to the power 4k plus 2. Hence, what is I square? So I square is minus 1. Hence, the answer is 1 upon minus 1. Or we can say minus 1 simply. Right? Okay. And I to the power 22. This is a very, very simple question. Anyone can solve this. You can divide it by 4. You will get the remainder 2. So I to the power 4k plus 2. Hence, I square is minus 1. This is how you can solve a very, very difficult questions in just seconds by these tricks, by the help of iota. So